So what this gives us an ellipse that looks like something like this. Okay, and this length is A and this length is B. So this ellipse's equation is the one that's given above. So let's do this. Let's find this area and times it by 4. Okay, so the total area must be 4 times integrate from 0 to A, right, on the x value, 0 to A, and you need to isolate your y. Right, so to isolate y, first bring the thing over like this, multiply everything by b now. So before I do that, actually, let me add this together first, and you get a squared minus x squared all over a squared, and then you're going to multiply by b squared. So if you isolate y, you get square root of b over a. Okay. So let me actually write this first. That, right? Then you can see how I can isolate, I can take out the b over a, right, to the front. So other than the b over a, it looks like the equation of a circle, isolated. So that's what you need to put there. Now note that I didn't have to worry about the minus case. It's usually plus minus algebraically, because I only care about the top part where y is positive. Okay, so can you guys try integrating that, please? Okay, so it's 4b over a, first of all, 0 to a, and the substitution that we need to make is that x is equal to a sine of theta again, right? So dx is equal to a cosine of theta d theta. So we get 4b a. And the number in the integral, for now I'm just going to leave it blank because I'm going to change it back. We're changing the theta, and we're going to change it back later to in terms of x, or change the 0 to a in terms of the angle. So we get a squared minus a squared sine of theta, and dx is equal to a cosine of theta d theta. So you can factor out the a squared as a, and you get 1 minus sine squared theta, a times cosine of theta d theta. Right. So look, this and this will cancel out. We have 4ab integral. So this will become just cosine of theta. We have 2 cosine, 1 cosine from here, 1 from here. So do you guys remember how to take care of that?
One minus or 1 plus cos 2x.
Yes.
2.
You gotta use the double angle formula, right? So we get 4ab over 2 integral 1 plus cosine of 2 theta. And then we get, right, if you integrate that, you get theta plus half of sine of 2 theta. And let's convert the 0 to a in terms of theta. So we have the substitution, x is equal to a sine of theta. And when x is equal to 0, right, sine of theta is going to equal to 0, right? So theta is equal to 0 too. When x is equal to a, you can see that the sine of theta will equal to 1. That means theta is equal to pi over 2. This makes sense, look. In terms of angle, right, we're pure integrating from 0 to a. In terms of angle, look, the rotation should be exactly 0 to 90 degrees. Okay, so we can change this to 0 to pi over 2. Okay. So 2ab, plug in pi over 2, you get pi over 2. If you plug in pi over 2, you get 0. Okay, if you plug in 0, you get 0. So really that's all you have left over. And your final answer is pi times a times b. Pi ab is the area of this ellipse. Okay. So note how similar the formula is to pi r squared. Right, circle, instead of a and b, it's just a and a, right? So it's pi a squared. This is different, so pi times a times b. Okay.